Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a look at centroids of volumes. In the previous two videos we looked at finding centroids of areas, and we're going to use the same idea that we did with areas, where the first moment of a volume, just like the first moment of an area, will be equal to the total volume times the distance from the axis to the centroid. So we're going to use this formula to find that distance to the centroid. It will equal the total, or the sum of the first moments, divided by the total, or the sum of the volumes. The way that we're going to find the sum of the first moments is through integration, and the way that we're going to find the total volume is through integration. So if we take a look at an area that's bounded by f of x as well as the x-axis, from x equals a to x equals b, and if we were to rotate that area around the x-axis, it would form a volume. We're going to be finding the centroid of that volume. Because it's rotating around the x-axis, that x-axis is already an axis of symmetry for that solid. So we already know one of the coordinates for our centroid. We know that y will be equal to 0, but we need to find the x value. And the way that we're going to do that is we're going to take the sum of the first moments through integration, and that sum will be from a to b, the perpendicular distance from the y-axis, so x, times the volume of my representative rectangle as this is rotating around the x-axis. So it becomes a cylinder, and that volume is pi times the radius. The radius will be f of x. It will be this y value squared, radius squared, times the height or the thickness of that cylinder or that disc, which will be dx. And that will be divided by the total volume. I'm going to bring pi out front, and I'm also going to bring total volume out of the denominator. So we could write this as pi divided by v, the volume, times the integral of from a to b of x times f of x squared dx. That's how we would find the x coordinate of this particular volume if this area was rotated about the x-axis. Let's take a look at an example. The question says, find the coordinates of the centroid of the solid generated by revolving the area bounded by y equals x squared x equals 1, and the x-axis, so this is the area that we're dealing with, revolving about the x-axis. So that area is revolving about the x-axis to form a solid. I find that students make the mistake of not reading the question carefully. Many of these questions look very similar, whether they're area questions, volume questions, centroids of an area, centroids of a volume, and we're also going to get into moments of inertia of areas and volumes. So just take your time when you read the question to figure out exactly what they're asking, because a lot of them will say the area or the region bounded by all of these things. You have to pay attention to where it's revolving. You have to pay attention whether it's a volume you're finding, or a centroid, or a moment of inertia. If it's not revolving, then it's an area, but are you finding the area, or are you finding the centroid of the area, or are you finding the moment of inertia of the area? So just read the question very carefully and look at your keywords. We know that this is a centroid question, and it's a solid of revolution, so it's a volume, and it's rotating about the x-axis. Because it's rotating about the x-axis, that becomes an axis of symmetry, and our centroid is going to be on that axis. So we already have one of the coordinates. We already know that the y coordinate will be 0 because the centroid is on that axis, and that's where y equals 0. What we need to find is the x coordinate of our centroid of our volume. Now, in order to find the centroid, I need to find volume, so I'm going to start there. I'm going to find the volume of this, and I'm going to be using vertical rectangles. It's rotating about the axes, and it's bounded about that axis, so I'm going to use a disk method. So my volume is going to be pi, the integral from 0 to 1 of the radius squared. This is the radius of that cylinder or that disc that's formed. So x squared squared times the thickness, which is dx. So pi radius squared times height. Simplify first and then integrate. So my volume will be pi divided by 5 cubic units. Once I have the volume, I can find the x-coordinate of the centroid of this volume. So the x-coordinate will be pi divided by pi over 5 cubic units times the integral from 0 to 1 of x times f of x, which is x squared squared dx. When I take pi and divide by pi over 5, I'm multiplying by 5 over pi, so that becomes 5. When I simplify this, it's going to be x to the 5th. And when I integrate it, it will be 1/6 x to the 6th. And when I evaluate it, it's going to be 1/6 times 5, which is 5/6. So I have my y-coordinate of the centroid, I have the x-coordinate of the centroid, so the centroid will be at the point 5, 6, 0. We do the very same thing when we're finding the centroid of a volume and it's bounded by the y-axis and it's rotating about the y-axis. So let's take a look at the formula and then let's do an example of that. So if we had an area bounded by f of y and the y-axis from y equals c to y equals d, and if that area were rotated about the y-axis, it would form a volume. We can find the centroid of that volume in the same way we found it in the previous example. When it's revolving about the y-axis, we know that the y-axis becomes an axis of symmetry. So we know that the centroid is on the y-axis, which means the x-coordinate will be 0. What we need to find is the y-coordinate. And we find it the way we did to find the x-coordinate in the previous formula. So the y-coordinate of the centroid of this volume can be found by finding the sum of the first moments, which we use integration to do that from c to d. And it will be, we're using horizontal rectangles, it would be the perpendicular distance to the x-axis, which is y, times the volume of that representative rectangle as it rotates around, and that becomes a disk. So the volume will be pi times the radius. The radius will be f of y. The radius has to be squared, times that thickness or that height, which is dy. So that will be the sum of the first moments of that volume, and we divide that by the total volume. And I'm just going to clean it up because we don't want to work with the formula in that form. We're going to pull pi out of our integral because we can do that, it's a constant. I'm going to take volume out of the denominator and just divide pi by it. And then I'm going to multiply by this integral. So this is the formula we're going to use to find the y-coordinate of this particular volume. Let's do an example. The question asks us to find the coordinates of the centroid of the solid form by rotating the region bounded by y equals x cubed. Y equals 1. Y equals 8. And the y-axis. So the region bounded by those 4 equations is this region right here. And if that region is rotated about the y-axis, it will form a solid. So because it's rotating about the y-axis, we know that that's our axis of symmetry. We already know the x-coordinate of our centroid is 0. What we need to do now is find the y-coordinate. In order to find the y-coordinate, I'm going to find volume first. I'm going to use horizontal rectangles, and when I find the volume, I'm going to be using the disk method because it's bounded by the axis it's rotating about. So the volume will be pi times the integral from 1 to 8 of, I have to have my function of y. I have a function of x right now, so if y equals x cubed, then x will equal y to the 1/3. So that's my f of y, y to the 1/3. That would be the radius of that disk that's formed. So y to the 1/3 squared times dy. So pi times radius squared times thickness or height. I'll simplify first, so that becomes y to the 2/3, and then I'm going to integrate. When I add a 1, that will be y to the 5/3, so it'll be 3/5 y to the 5/3. Let's bring the 3 pi over 5 outside, and I'll have 8 to the 5/3. Cubed root of 8 is 2, 2 to the 5th hour is 32, minus, when I put a 1 in there, it'll just be a 1. So it's going to be 31 times 3, which is 93 pi over 5. Now let's find the y-coordinate. So it's going to be pi divided by 93 pi over 5 times the integral from 1 to 8 of y times f of y, which is y to the 1/3, dy. Pi's will cancel, and I'll have 1 over 93 over 5, which is 5 over 93. Simplify this, so that will be y to the 2/3 times y will be y to the 5/3. I'm going to integrate that. It will be y to the, we add a 1, it becomes 8/3. We divide by 8/3 would be 3/8. Now 3 divides into there once, 3 into there 31 times. So we will pull the 5 over 248 outside of the calculation. Put an 8 in, cubed root of 8 is 2, 2 to the 8th, minus 1 to the 8/3 will be a 1. When I do this calculation, it's 255, times it by 5, divide by 248. It's not a great fraction, so I wrote it as a decimal. Therefore, the centroid is this point right here. So my biggest piece of advice is read the question carefully. Make sure you understand what the question's asking and set up your integral accordingly. The next application we're going to take a look at is moments of inertia. So take care and see you then.